All right, so this is the new lesson for Monday. We're looking at same concept, find an integral using a U substitution. This is a skill that we're going to work on a bit. It kind of takes a while to master it. At some point in time, you'll get to the point where you say, hey, this is easy because I can immediately spot what I should use for U. But at first, it's almost kind of convoluted because every case is a little bit different. Every time you're like, okay, what is the U hiding inside a function, right? You got to kind of figure out, what function do I have with something that would be inside that would use the chain rule, and that's what I need to set U equal to. So let's take a look. I think we've got 3 examples here. First example, it looks like there's something inside a square root symbol, so I'm going to guess that my U is going to be that 7x to the third plus 5. Take the derivative, and let's see if the derivative matches up with anything in the integral. Sure enough, if I take the derivative, I get 21x squared. I see a 21x squared in the integral. So my hunch is I've successfully found my U. Multiply both sides by dx, and I know my U will be 7x to the third plus 5. And I know my du will be the 21x squared dx. So I'm left with the integral, and I'm left with the square root. So the integral, square root of U, du. Well, before I integrate, I got to remember that square root really means 1/2 power. So when I do integrate, add 1 to the exponent, divide by the new exponent. I never really want to divide by a fraction, so I multiply by the reciprocal. And now for my back substitution, U is replaced with 7x to the third plus 5. Of course, if I want to check my answer, let's take the derivative. When I take the derivative, that old exponent of 3/2 becomes a coefficient. Subtract 1 from the 3/2, I get a half. Take the derivative of what's inside, and I get 21x squared. The plus c, of course, just cancels out. Derivative of constant is 0. 3/2 and 2/3 cancel each other out. Sure enough, the derivative matches what was inside the integral. Second example, 8 times the cosine of x sine to the 7th power x dx. And I need to integrate that. Well, how about U equals sine of x? If I take the derivative of sine of x, I get cosine of x. So it looks like du will be cosine of x dx. So sine of x is my U. Notice that the 7 is not included with that, right? That will become U to the 7th power. The cosine x dx will be my du. I'm like, I'm left with an 8. That's okay. 8's a plain old number. It's just a coefficient. So I keep my integral symbol. I keep my 8. Instead of sine of x all raised to the 7th power, I just have u raised to the 7th power. Cosine x dx gets replaced with the du. Add 1 to get the new exponent. Divide by the new exponent. 8 over 8 cancels out. Instead of u to the 8th power, I can back substitute. So the sine of x gets raised to the 8th power, but I got to remember that since the entire thing's being raised to the 8th power, I write it as sine to the 8th power x. Right, so that way I know the entire function is being raised to the 8th power, not just the x. If I want to check, the derivative of sine is cosine. Whoops, let me double check that. If I want to check anything to the 8th power, if I want to take the derivative, the 8 will go out in front as a coefficient. Subtract 1, the new exponent is 7. And now the chain rule says take the derivative of sine and you get cosine. I jumped the gun on that one. But sure enough, it works out. A third example here. Again, what should I have for my u? Well, it looks like sine of x is a good candidate for my u because I've got e raised to some power. And what is that crazy power? Well, it looks like sine of x, but of course I know that the derivative of sine of x is cosine of x. So okay, let's make it sine of x. Because if I take the derivative, I get cosine of x. So I'm thinking, okay, my u can be sine of x. My du will be cosine of x dx. Leaves me the integral symbol and leaves me the e. So I need to take the integral of e to the u power du. Easiest integration of the bunch. Integral of e to the u, of course, is just e to the u, plus a constant because it's an indefinite integral. Back substitute. And if I want to check, take the derivative. The derivative of e to the sine of x, of course, is just e to the sine of x. Chain rule says, hey, you better take the derivative of sine of x, which is cosine of x. And there it is. It matches what was inside the integral symbol. I know I've taken a lot of the animation out, but I was just too happy with this one to remove it. And there we are, happy working.